Good day, everyone. I am Sir Roy, and for today, we're going to talk about the types of plate boundaries. According to plate tectonics theory, the surface of the Earth is broken into large plates. The size and position of these plates change over time. The edges of these plates, where they move against each other, are the sites of intense geologic activity. These edges are what we call as the plate boundaries. Now let's have the definition of the word plate boundaries. These are the edges where two plates meet. Now let us analyze and describe the movement of the following tectonic plates. We have figure 1, figure 2, and figure 3. In figure number 1, we can see that the tectonic plates move towards each other. In figure number 2, we can say that the plates move away from each other. On the other hand, in figure number 3, we can say that the plates slip past each other. But how do we call the following plate boundaries? Let us have the types of boundaries or plate boundaries. Number 1, we have what we call as the convergent boundary, a boundary in which two plates move toward each other, causing one of the slabs of the lithosphere to subduct beneath an overriding plate. The second one is divergent boundary, is a region where the crustal plates are moving apart. And the third one is what we call as a transform fault boundary. It is a boundary produced when two plates slide past each other. Let us remember the following clue words. For convergent boundary, we have move towards each other. For divergent boundary, we can say that plates moving apart. And for transform fault boundary, the plates slide past each other. Let's go back to the figures. We can say that figure number 1, since they move towards each other, it is what we call as the convergent boundary. Next, figure number 2, since they move away from each other, it is called as divergent boundary. And the third one, since they slip past each other, it is now called as transform fault boundary. Now let us have the different types of convergent plate boundaries. The first one is what we call as continental to continental convergence. It occurs when a continent or large island that has been moved along with another continent. In this particular case, the continental crust converge with another continental crust. The colliding continental material will not be subducted because it is too light, because it is only composed of light continental rocks. But the root of the oceanic plate will eventually move or break off and sink into the mantle. There is tremendous deformation and pre-existing continental rocks, forcing material upwards and creating mountains. Examples of continent-to-continent convergent boundaries are the collision of the India plate with the Eurasian plate, creating the Himalaya mountains. Oceanic to continental convergence. At an oceanic continent convergent boundary, the denser oceanic plate is pushed under the less dense continental plate in the same manner as an ocean-to-ocean boundary. Here, as you can see, there is a convergence between the oceanic crust and a continental crust. The sediment that has accumulated on the seafloor is thrust up into an accretionary wedge and continental plate. The magma, produced adjacent to the subduction zone, rises to the base of the continental crust and leads to partial melting of the crustal rock. The resulting magma ascends or goes up through the crust, producing a mountain chain with many volcanoes. As with an ocean-to-ocean boundary, the subducting crust can produce a deep trench running parallel to the coastline. Example of land formation in an ocean-to-ocean convergent zone are what we called as Marianas Trench. Next one is oceanic-to-oceanic convergence. At an ocean-to-ocean convergent boundary, one of the plate's oceanic crust and lithospheric mantle is pushed or subducted under the other. Often, it is the older and colder plate that is denser and subducts beneath the younger and warmer plate. There is commonly an ocean trench along a boundary as the crust bends downward. What are the different landforms found at the plate boundaries? Let us talk about them one by one. The first one are what we call as deep ocean trench. The type of plate boundary is convergent. As the more dense oceanic plate subducts under the less dense oceanic plate or continental plate, it pulls down the front edge of the less dense plate down, creating a deep zone known as the trench. The next one is what we call as volcano. The type of plate boundary is also convergent. The more dense oceanic plate subducts under the less dense continental plate and is driven down into the hot asthenosphere or mantle. Subducted plates melt due to extreme heat and friction. Melted plate rises up through the crust where it reaches the surface and cools. Happens repeatedly to create large volcanoes. The next one is what we call as volcanic island arc. The type of plate boundary is again convergent. The same process that forms volcano on land. Subducted oceanic plate melts and rises to reach the surface of the oceanic plate. This happens repeatedly, building and building until the volcano breaks the surface of the water and creating a chain of islands along the subduction zone. Another land formation is what we call as folded mountains. The type of plate boundary is again convergent. Two continental plates collide. Continental plate is not dense enough to subduct. As a result, the continental crust folds upward, creating a chain of folded mountains. The next one is what we call as the Rift Valley. The type of plate boundary is divergent. Two continental plates move away from each other, stretching out the crust until it begins to break or to cause a crack. As the crust is stretched wider, the valley drops deeper, eventually can lead to the creation of a new body of water if low enough. And the last one is what we call as mid-ocean ridge. The type of plate boundary is divergent. Here, two oceanic plates move away from each other, allowing magma to rise up from inside the earth. The magma reaches the bottom of the ocean, turns into lava, and cools, forming new rock. This cycle continues, constantly spreading the seafloor and adding new material along this chains of mountains. That's all. Thank you for watching.